In 2009, a group studied the ambiguity of words like association, average, confidence, random, and spread among students and teachers. They described that students tend to use the word random to mean haphazard or something that happens with small probability, almost on accident. When in reality, if something is statistically random, it's not haphazard at all. In fact, it's often quite structured. A 2004 study investigated elementary teachers' ability to display and interpret sampling, distributions, and probability. They made a few striking discoveries. Although teachers had a good initial sense of essential tendencies like mean, median, and mode, they had difficulties predicting spread of data, often including too little variation or overly extreme variation. They also often took an anything-goes stance when it came to something that was random, and felt that therefore they couldn't make judgments about the outcomes. But that's exactly what we do in statistics. We make judgments about outcomes, and we use randomness to do so. Not only is it not problematic, it's crucially important. So if randomness doesn't mean anything goes and low probability, what does it mean? In general, random refers to the lack of predictability. Random drawings are used to determine lottery winners. Some sports use coin tosses to randomly select starting conditions, while clinical interventions often use randomized controlled trials to reduce bias. In fact, randomness has been used for games of chance throughout history, including picking people for an unwanted task in a fair way, like drawing straws. In statistics, events are called random if the outcomes cannot be accurately and precisely predicted, like the sum of the numbers on two rolled dice, as opposed to deterministic events whose outcomes can be accurately and precisely predicted, like the amount in your savings account at the end of the month. A variable is often called random if its value isn't fixed and depends on outcomes of a selection process or experiment, like the height of a person who hasn't been picked yet, as opposed to algebra where a variable, even when unknown, is fixed, like the area of a circle once you know the radius. In practice, events tend to be part random and part deterministic, and these are called probabilistic or statistical. These are events where you know something will happen, you just don't know when, like rolling a die until a 5 comes up. We don't know exactly when it will happen, but we can make predictions when it is likely to happen. One of the most common uses of randomness in statistics is through sampling, specifically random sampling and simple random sampling, when either each individual has the same chance of being selected, or each potential group of the desired size has the same chance of being selected. This is what allows surveys from groups of people to provide data that is reflective of the population. Selecting people at random from a population you want to know about makes it more likely that your sample of people is representative. If people aren't randomly selected from the population you want to know about, then you don't know if your sample is representative, or in other words, if your sample is biased or not. Say you have given out a survey and you want to know if your sample is biased or not. So you ask yourself, are certain people more likely to partake or be selected? If yes, this is an example of self-selection bias, like how parents who are proud of their parenting are more likely to want to talk about it via a survey. Are some people refusing to participate or dropping out in a systematic way? If yes, this is an example of non-response bias. For example, some people ignore calls from unknown numbers or refuse to answer polls about voting. These are only two possible sources of bias, among many, many others. Remember, the goal here is to have a selection process that ensures that the sample is representative of the larger group you're interested in. Say you and I both sample 10 students from the same campus. I pick 10 students in a random sense, in that they all have the same chance of being sampled by me. You pick your 10 favorite students. Not random at all, but deterministically. Can we end up with the same 10 students? Yes. No matter who your favorite 10 students are, it's totally possible that I will pick them too. Likely? No. But possible? Yes. Can someone know whose sample was random and whose was not by looking at them? No. Especially if they're the same. It's the processes that are different, not necessarily the outcomes. If both samples end up being the same, who cares? One of the main points of random sampling is to prevent bias. The chance that I pick 10 students who are representative of campus is high, since everyone had the same chance of landing at my sample. I don't need to worry about the students who are not representative of campus, by definition, since they don't account for the majority and won't be selected as often as those who are. You will always pick your favorite students, so your sample will always be weighted towards your personal preferences in students. You cannot test if data was collected at random after the fact. Collected data is determined to be random because of the process used to collect it, not the result of the process or the data itself. It's like a recipe that must be meticulously followed. While some recipes can be resurrected from a few mistakes or complete failure, this typically isn't one of those recipes. There are tests that attempt to quantify how random a sample might be, by simulating massive amounts of data, forming a distribution from that data, and analyzing how the actual data compares to the simulated data. These rely on hypothesis test style frameworks within decision theory, which does not guarantee anything regarding the sample in question. In practice, you make sure your process is as random as possible and trust that all goes well. If you're thinking that this sounds messy, unclear, and has more gray area than not, you wouldn't be wrong. Randomness is hard to nail down, but is critically important, especially in statistics. In short, simply asking yourself questions like, if I wanted to know more about a group of people, who would I ask? And this news article looks great, but who did they ask, and who are they supposed to represent? You'll be miles ahead of, did you see the latest poll results? They were so random. If you liked this video or would like to hear about other topics, subscribe, hit the like button, and leave a comment.